you. Thank you. All right. Thanks very much for coming here. I really appreciate it. Okay, so my name is Vidya. I am responsible for the data function, as the intro just now, for a company called YouView. So a lot of people may not know what YouView does, so I'd like to start with that. So YouView, if you are a BT TV customer, or you are a TalkTalk TV customer, or you go into a retail shop and you're buying a bunch of Sony television models, what you're actually getting is a YouView product, right? So YouView is responsible for the tech stack, most of the tech stack, and the user experience that is delivered with that tech stack that enables millions of customers in the UK to watch television every day. Yeah, so that's our business. In terms of my responsibilities in the team, it's three things. It is making sure we're backhauling the right sort of data. It is prioritizing what our data engineers work on, and it is getting value out of our data in terms of helping our business make decisions under uncertainty, right? So that, and as well as powering viewer experiences and so on down the future. Okay, so with that, product experimentation is not that easy for us, okay? Because we have a very deep, very complex tech stack. We deliver user experience, content delivery experience that involves multiple different partners. So actually, the time to development for some of the things can be longer for us to be able to test and learn. So we're very much, I would say, in the grand scheme of things, at the earlier stages of what test and learn looks like for us. So what am I going to do today? I'm going to tell you a story in chronological order of how we have had to bootstrap the cultural parts of test and learn experimentation, as well as the technical capabilities that we've had to build up in order to be able to do so. This is not going to be a talk about randomized control testing. It's actually going to be a talk about how we can get value from our data that is, even when the experiment isn't quite designed the way that the gold standard might look. Okay, and then I'll talk you through examples of experiments. Those are just the background in many ways for the talk. They are pivotal moments in our journey so far. It's not to say those are the only experiments, but basically those have been pivotal journeys, and really my emphasis is going to be around the culture and the capabilities around that. Okay, so with that, the first one that I'm going to talk to you about is an initiative around SD to HD redirection. So to give you a bit of context from a user experience perspective, what we were looking to do is when a person would land into a standard definition version of a channel, we would want to either give them a prompt or automatically redirect them to a high definition version of that channel. And the motivation behind that is most people, when they open up a guide, if you're familiar with what that looks like, the standard definition channels are towards the top. Yeah, so you're more likely to find them, and you're not going to find the higher quality, the higher definition content further down in terms of channels. So what we want to do is show our viewers perhaps they actually have entitlements to those higher definition channels, and they didn't know about it, so let's prompt them to have that richer experience. So that's the UX context to this, and I'm now going to give you a little bit of a baseline of where we started to help put the rest of what's coming in perspective. So for various valid reasons, the data team, the data science team had no influence over how this experiment was set up or what was run. So that meant no influence over group selection, no influence over how long things were run for, no influence over how many people, nothing. Yeah. So what was worse was, as we were going through the experiment, we still didn't know what we were measuring. Yeah, so we were still talking about what good looked like and what the concrete, in quite precise terms, what that looked like. So what was the outcome of this? I'll tell you a lot more detail, but basically this analysis to hand a result over to say, here's the impact of what this particular initiative took us weeks, took us months, yeah? And what that meant is loss of traction and all sorts of other business impact we can talk about later. And what we also found was, so this amazing change that we thought we made, we can't see an effect, but we'll come to that too. Okay, so why did this take long? why this took long was because we rolled this experience out to some trialists. Now, these trialists behave nothing like the rest of our base. Yeah? So trialists tend to be more engaged in a product. And to make things a little bit worse from a design perspective, we also told them that we were trying something out with them, which meant that there are well-known effects where when an individual knows that they're being observed, their behavior is likely to be changed as well, right? So we had all sorts of issues around that. And what that meant is when the experiment was then over, we almost didn't recognize what this was one of, right? And we had to decipher that. Okay, so what did we do? Right. So this is a very quick intro into a technique called difference in differences. Many others exist. At a high level, let's say that you've got a metric and there is time on the horizontal axis, and then you've got the value of that metric over the vertical axis. It doesn't matter what that metric is for the purpose of this. And let's say that there is an intervention. So there is a treatment that is applied to a specific group of individuals at a specific point in time. For the purpose of this example, we'll assume that everybody who was going to be treated is going to be treated on the same day, right? So if I'm going to be treated, and so are you, for example, both of us will switch to the new experiment on the same day, and that's also usually not the case, and the technique does have mechanisms to extend in order to be able to deal with staggered effects and things like that. Okay, so then we have a pre-intervention period and a post-intervention period, and there may even be many, and that's also okay, so the technique extends to be able to deal with that. And then when we look at, I've summarized our data points with one data point, just one average value, for example. So our treatment group is sitting on the top as the circles, and our control group. And what you immediately see, both in the pre and post periods, is that the treatment group, the metric value in itself, is much higher. Not really that dissimilar to our trialist example, right? Where trialists do more of that behavior, and so on. And then what we see is that there is potentially some change in both groups, irrespective of treatment. So fundamental to the difference in differences technique is the assumed counterfactual. So the assumption here is that groups that may not be randomized, if they still move in tandem, which is called the parallel trends assumption, if the groups still move in tandem, we can potentially infer what the value for the treatment group could have been if they did not experience treatment. Yeah, so that's the assumed counterfactual, but what must hold true is the groups have to move in tandem, right? So that must hold true. Okay, so in this case, what we can then do is we are looking to estimate what the actual effect size is, and we can do that. It's really simple in concept. It's that value minus that value, subtracted that value minus that value. So effectively, you're trying to create that value and then trying to figure out what that difference is. Yeah, so it's really straightforward. Okay, so this is usually done through a simple regression equation. That's just what the equation looks like. There are many other extensions where you can add additional control variables and all sorts of things, but effectively, in a really simple way, we work with individual observations, so individuals pre-post, and you can have multiple observations as well. So the equation is really simple. It is there's a constant term. There is there's a variable that captures which group you're part of. Are you part of treatment or control? And then there is a time. So are you in the post time period or the pre time period? And then this is the most important coefficient for the purpose of this, for what we're looking for. And it's capturing an estimate for the interaction between group and time, because we're not just interested in what happens over time. We're not just interested in what happens because you're part of the treatment group. We're interested in what happens when you're part of the treatment group during treatment time. Yeah, so that's where that interaction term is coming from. And then there is an error term. There are some assumptions around randomness in that error term worth looking into before you're using this technique. Okay, so with that, we went through all of that. We went through reading a lot of it, trying different things out to validate that this was the right thing for us at that time, and we found nothing, right? So no effect. Why not? So this regression term, just like any regression equation, you get for that estimate, you get p-values and confidence intervals, which we can reason with. We found nothing, and that was because the group sizes that we were working with were very, very small. So this is called an experiment being underpowered. So another way of looking at it is the variation that was being, the variation just within the individuals that were going to be treated was so much that if there was any change that was being introduced because of this experience, it could not be observed, right? So it couldn't be detected. So that was what we had. So we said this to our stakeholders, and we said, sorry, we didn't see anything, probably because the group was too small, right? In a really simple way. And then they said, aha, so if we actually rolled it out to everybody, you're saying we might see something, right? Which is counterintuitive, right, in comparison to what we might hope for in that discussion. So, however, the result did show that there really wasn't anything in this setup, and the conclusion really was that whether there was really anything or not, the experiment design did not do the initiative justice, right? So we couldn't find anything, and the caveats around that left us a little bit in nowhere land, right? So, and that was a shame for that piece of work. So it was baptism by fire, yeah, so in that example. So we learned a lot. Here are some of the things that we learned. So the first thing, we had to, as a priority, introduce and embed experiment design principles within our decision-making teams. So thinking about what's important and how that's measured and things like that was a really high priority. We were no longer shying away from not having randomized control, because there is an ocean of techniques within causal inference that allows us to still provide statistical rigor with caveats, with assumptions, when randomized control is not possible. And that was really empowering for our business, where we had previously shied away from some of that in the past. The third thing, it was time to build. It was time to build capabilities, because what really mattered was time to insight, time to that information, because the longer we took, the less traction the whole piece of work potentially had, and the less relevant the data science team was to the business. Right? So that was something that we then had to focus on. Okay, so that's what we learned. Scene 2. Next experiment, time goes on. We've been building up what our capabilities was. This was a golden example because it was actually randomized control testing, okay? So we were fortunate to be able to do that. So, however, we knew, I said earlier, that we need to focus on experiment design and helping our decision makers articulate what is important. So we focus a lot now on how we create hypotheses and so on. These are just some examples to provoke further reading, if you'd be interested in this area. So, for example, the top right is a good summary of how a hypothesis may be created, but it's effectively, if we apply this, i.e. whatever UX experience you might be looking for, then this behavior change will happen, which is quantifiable through a metric, among this group, because not all changes are necessarily impacting the whole population because of this reason. And that is coming from either psychology or, user experience feedback, or, user research, or other insights that may exist, okay? And a kind of a more detailed version of that is what's on the left, which I really like. So that also provides a clearer link if you are of the frequentist mindset. It also gives a clearer link from that business-friendly hypothesis to the metrics and null hypotheses and alternatives and things. So it gives you a very clear link on the left side. Links are right there if you want to look into that a lot further. The other thing that a business usually also faces is decision paralysis. So we are all human. We all want to know everything of what might be possibly happening. So we might end up then measuring lots and lots of things. Not a good idea. I'll come to that. But actually, we might end up measuring several things, and then one metric went one way, one metric went the other way. What are you going to do now? Yeah, so that leads to decision paralysis. So there are a number of frameworks that are proposed in this space. So one thing is around an overall evaluation criteria, which is proposed by someone called Ronnie Kohavi, very well known in this area. And that is about a composite metric that the business needs to buy into, that everybody pulls towards. Here's another example, which is from an experimentation provider called Optimizely, if you're familiar with them. And the proposal there is around primary, secondary metrics and monitoring goals, where the primary metric makes or breaks the deal for whether something is successful or not, and then followed by secondary metrics, monitoring goals, which give you some sense of hierarchy. Yeah, and the punchline of all of that is you need to think about it before you see the answers. Okay, so with that, what did we do on the stats side of this world? So what did we do here? So 2 parts: experiment design and experiment analysis. Experiment design, really straightforward, because this was randomized control, right? So define metrics, I've said a little bit about that. What we do in our business at the moment is a combination of some of the things that I showed earlier, where our decision makers articulate what the objectives are, and we are talking about what we want our viewers to do, as well as what we want our viewers to avoid. So what's the price we don't want to pay? Yeah, so we also think about that, and that allows us to have some very viewer-centric hypotheses and some clear measures and things like that. Okay, so here we're defining some metrics, nice and straightforward for this moment, and things like calculating a sample size, all of this is bread and butter. It's on a website, yeah. So because it's randomized control, and these were continuous metrics. So, and this is fairly straightforward. And for those of you who may not be familiar with it, the idea behind it is you want to know how many people you need to have in your experiment in order to have some degree of confidence. It's not the right word for for seeing an effect if it is there, and not seeing an effect that's actually not there. So controlling for false positives and false negative rates, right? So with that, roll out the experiment for X weeks. X, subject to seasonality. So ours, TV viewing, is a very seasonal business, and therefore that plays a strong part in how long we need to leave our experiences out in order to be able to have a good degree of confidence that it is representative. Okay, and then on the experiment analysis side of things, one of the things that we started thinking about at this point is to control for family-wise error rate. Okay, so family-wise error rate, and it comes in a slightly different guise called false discovery rate, is where family-wise error rate is the probability that at least one of the metrics that you are doing a hypothesis test on, if you have more than one, gives you a false positive. So, for example, if you have 4 metrics, if you have 10 metrics, not a good idea. Let's say if you've got 10 metrics that you're doing hypotheses tests on, there is a 40% chance that you can actually see a result that's not there. Yeah, so, and that's quite a high number to be declaring false winners, to have at least one of those. So there are methods out there to be able to control those. Really simple one is something called the Bonferroni correction. There are several alternatives. What we actually use is something that is through simulation. So we use Monte Carlo simulation for that as well. Okay, so then the next thing that we do is we actually use bootstrapping to create the typical things that you create, so p-values and confidence intervals. So I've provided a link on the bottom for those who want to go and watch some videos on this a little bit later. So the idea behind something like creating a confidence interval through bootstrapping is that if we've got your the actual test control the values themselves for each individual. The idea is to sample with replacement, to calculate the test statistic, which is whatever is the metric that you care about, the difference in means, whatever that might be, to do that over and over and over, to create a distribution of values that you can then use to say, okay, what's my 2.5 percentile value of that difference in mean? What's my 97.5th percentile of that value in difference in mean? And that gives you some sense of how much variation you can expect if, and so on. So it's an alternative to the classic t-test and so on. It doesn't make assumptions about the distribution of data. And if you've got compute, which is what it needs, you have a very intuitive understanding for both within the team as well as our stakeholders in terms of how this comes about, how what we're looking at comes about. Okay, and then we presented those results to our stakeholders, and everything was amazing because we saw the direction of travel that we were looking for. It clearly showed, because we had thought about what was important, it clearly showed us that this particular initiative was going to move our business in the right direction in terms of what was important to us. So what did we learn? We learned about external validity. So even though this was randomized control, the group to which the experience was randomly rolled out, the whole group was not representative of our real customer base. Okay, so our real customer base has different features available to them, different UI screens and capabilities available to them. So therefore, the group that we had rolled out randomized this experiment to was not representative. However, having said all of that, the user experience that you would now see if you open a YouView set-top box, the home page that you now see came out of this work, right? Okay, number 3. So a new kind of TV guide. So a little bit of context about the user experience to begin with. For those of you who are familiar with a guide or EPG, can I just have a show of hands for how many people actually know what that UX looks like? So how many people know what a guide is, an EPG is, and so on? Okay, this is a streaming world. A guide is traditionally a little bit like a spreadsheet, and the idea behind it is that viewers who are interested in perhaps live content primarily can see what's on, what's coming later, what's beforehand, etc., etc. They can interact with that content, favorite, bookmark, set recordings, any number of interactions are possible, and more importantly, you can tune to watch it. So that's what a traditional guide looks like, and what YouView was looking to do is to move us more towards a different form of a guide, one that was far more rich in its imagery, as well as one that placed emphasis on what was actually broadcasting right now and what was going to be showing immediately following, as well as blending that experience with on-demand content, quite representative with the number of hands that went up. So blending that with on-demand content in order to expose viewers to what they could be consuming on demand with that particular channel provider. So that's the context. There were 2 changes that were going to be back-to-back. We were going to be releasing one part of the experience first, understanding impact, and then in releasing an incremental follow-up to that to understand what was the impact of each of them, etc. Okay, so some constraints that we had to work with for quantifying impact in order to determine the success of this initiative. So a few constraints. The first one, this feature, there was no way that this feature could be released to a population where randomized control was going to be possible, because this particular feature had required a faster box, so in simple terms, and that meant that we could only release this to a part of our customer base. So the second part is high development effort generally means a high level of inertia for the business to discard to discard that work. So you've put months of effort into creating this new thing. You've really done your due diligence. You think this is the next best thing. And some results comes around and says, actually, maybe it didn't do what you thought it was going to do. The barrier at that point to let go is very, very high. Yeah, so, and that was something that we were very keen to help our business navigate through, and I'll talk about what that meant later on. Then we also had to do back-to-back experiments. So you've probably gathered by now that you're at YouView at this time. We are, in order for you to do one of these experiments that is not quite randomized, you need the support of the data science team, and therefore here the time to insight, because in order to be relevant to the business, in order to actually inform decision making around the success of these initiatives, we really had to step up our game in providing results that were timely. Okay, so what did we do? We started building up our capabilities in knowing how much of a population we need to go with. We're still working in frequentist world, but basically we traditionally, for randomized control testing, a sample size estimation is super straightforward, right? However, when you have quasi-experimentation and you want to know what is the size of the population that we should release this particular feature for in order to be able to quantify impact, it's not that straightforward. And there are a few different options, but this is, there's a link there for those who might want to read a little bit further, but effectively one can use Monte Carlo simulations in order to artificially inject an effect and then to observe over time how often that effect is actually observed, how often an effect is actually observed, right? So it's using simulations and a lot of compute in order to figure out roughly for any sample size that you might be interested in, what's the size of effect that we might be able to observe or not. Okay, so then what we looked at is various different techniques. Now this is, world's your oyster at this point. So some candidates that I'm just mentioning for reference for those who may want to look into this further. So interrupted time series and a variant of that. So control interrupted time series is a time series based technique. There we go, big hint. And then the control version is where if interrupted time series works if you don't have a control as well, and then the CITS version works if you've got a control, which is better, and so on. Then regression discontinuity design, another technique in our arsenal. Propensity score matching, this is where if we have visibility of various confounders, so other factors that may influence the likelihood to be treated or the likelihood to respond to treatment, then you can start to control for them. Yeah, so there are simple techniques and then more complex ones like propensity score matching, which is using simple machine learning models to try and match individuals. Then there are causal discovery techniques out there as well. So really powerful. So those are some packages in this space, but the idea behind some of them is to discover a graph of how variables are confounders, influences into your treatment are impacting each other and impacting the output variable that you're interested in measuring, and then you can then start to control for some of those variables. There is really good recommendations with, for example, the backdoor criterion and so on from Judea Pearl's work to know which variables are worth controlling for and which variables are actually introducing bias that you don't want, so are actually bad controls and so on. So with that, the other thing that we did is we had to focus our time in standardization, so in different forms. So firstly, we wanted our stakeholders to always see output that looked similar, right? Because it was hard enough for people to get their head around what the findings were showing every time. We didn't want slightly different answers, slightly different structure every time. So we focused our effort in standardizing what that output looked like. We also focused our effort in standardizing the process itself because we were looking to democratize, at least as a minimum within our team, and expecting individuals to know the ins and outs of what we were doing meant that some of our techniques things could be more error prone, right? So we were looking for putting layers of abstraction in place and things like that to be able to democratize the adoption of some of what we were building up. And then we also started putting more effort into thinking about consolidating our measures as well. So something that can happen as experimentation takes up is one part of the business or one set of decision makers pull in one direction and another set of decision makers pull in maybe a complementary, but if you're unlucky, an opposite direction, right? So then there is a need for consolidating what we're all pulling towards, and that's also something that speeds up the time as well in having here's one we made earlier. So with that, so we were putting a lot of effort into standardization, which was really helpful. And these 2 experiments went ahead, was fine. And then we had our findings. Some were intuitive and were in the direction that we were hoping for. Some showed no effect, and that was fine because we had prepared stakeholders for that. And some showed very strong effects in the opposite direction to so very counterintuitive effects that we were not expecting, as is the case. So what did we learn out of that? We've learned that we need to enable our decision makers to write down their expectations ahead of time. So after seeing some counterintuitive results, we are all human. We look at that and we go, but that does make sense, doesn't it? And that's okay. Yeah, so post hoc rationalization, right, is very common. So actually, what we started doing is empowering our decision makers to articulate ahead of time what they think is going to happen, so that there was a clear opportunity to be able to reflect on what we thought was going to happen, why we thought that was going to happen, and to be able to learn from what actually happened. Right? So that was really helpful. That is quite powerful for us. The second thing, we started writing our hypotheses differently for some types of experiments. Okay, so some of our releases and what we try out they're enablers for the future, right? So you're releasing something that's going to set a baseline that's then going to open up opportunities to do other things. Some of our changes are contractual requirements as a function of who we are, right? So with that, it was long thought, well, why bother measuring? We're going to have to do it anyway. It's going to roll out, whether it's going to roll out, right? So whatever it is. But actually, it turned out that the development teams were going through a phenomenal amount of effort to think about how to protect the experience, right? So that nothing regressed. That was actually, there was a lot of effort being put into that. And really, the conversation then becomes about not just what are the things we want to improve, what are the things that get better, but also what are the things that we want to maintain, what are the things that we want to not drop. And what that has meant from an experimentation adoption perspective is where previously we had perhaps as a business thought to ourselves, oh, why bother? It's going to roll out anyway. Why bother measuring? Well, here's why, because you don't want it to get worse. Right? So, and that was really powerful, opened up the opportunities for the business to go, yeah, I definitely want to know that because I'm putting a lot of effort into doing that, right? So that was really helpful. The third thing, now there was a need for a backlog, right? So effectively, our business, our stakeholders were clearly saying, so what do these findings actually mean for the objectives and hypotheses that we were trying to change in the first place? How well are we meeting them? And what could we be doing differently? Well, there's a backlog, right? So there are open source tools out there for democratized experimentation backlogs. Feel free to take a look. Yeah, so there are different ways of doing that, and also cataloging past experiment results and so on, which also becomes quite important to encourage that culture of reflection. Okay, so with that, where are we going now? New applications. So I've talked about product and UX and feature experimentation, but actually we have a very different customer who could very much benefit from what we're doing on this side of the forest. So our in-life service quality teams care about being able to detect regressions on key measures as early as possible, right? So however, what they can't do is wait around for 2 weeks. Yeah, because if there's a regression, they need to know now. So that opens up that means that we're either going down one of two paths. Either we're going down, if we are staying with the frequentist view, we're going down like sequential testing, and there are some techniques like SPRT and things like that in that space. Or far more likely, we're going down Bayesian hypothesis testing, because the outputs that come out of Bayesian hypothesis testing are also very intuitive. Things like a credible interval are really intuitive for a stakeholder to understand, as opposed to a confidence interval, which actually really isn't. Right? Okay, so the next thing that we're focusing on is self-serve. So you've already picked up that you can't run one of these without someone from my team, and that isn't scalable. So really, we want to start democratizing the capabilities themselves in order for increased self-serve within the business. Third thing, we want to start looking at increasing the sensitivity of the capabilities that we have. So incorporating things like anomaly detection into how we create our metrics, so that we are reducing the variance of our metrics. And with the same size of group, we're able to see smaller changes. Yeah. So there's some work that we're doing in that space as well. With that, and last but very much not the least, we're hiring. So we're hiring data engineers, we're hiring analysts, we're hiring data scientists. Come talk to me if you're interested in any of what I'm talking about or the wider TV data space. Thank you. Open to questions.
Thank you, Vidya. Okay, if you can put your hand up if you have a question, and I will try and get around with the mic. Sorry, the light's shining in my eyes. Any questions? We've got a limited amount of time for maybe one or two. Gentleman at the back. Anyone else, if you want to keep your hand up?
Thanks. It was a really interesting talk. I guess what I'm interested to know is when you start off trying to build a culture of experimentation, there's a lot you can do. As an example, you spoke to Bayesian results being more interpretable than frequentist ones. How do you choose which to prioritize if you're starting from scratch?
Yeah, we prioritize by value. So we prioritize by what is the most important investment at this point in time that will show us evidence to go down the path further. So how do you, it's very much, so we do agile development as a whole team, and what that means is what's the next iterative step what's the next milestone, what's the next iterative step we need to take in order to be able to discard or continue with what we want to do after that. And that is, I think what I probably should say with this is our technical capabilities and culture conversations are driven by the use cases we need to support within the business. So our customers' roadmap and what they need to have in place is what drives the technology that we need to invest in, and the cultural elements and frameworks and things like that we need to invest in. So that's why when we started off all of our work, really simple stuff made a lot of sense, right? Whereas now we're thinking, there's a different application here, but as we are renovating our capabilities and investing in new things for new areas, we're not keen on building pockets and silos. It's really how do we consolidate this approach across everybody, and that is then uplifts elsewhere as well. You see, so it's always prioritized by value, and then it is taking a more step back, holistic picture across the lot, not just that pocket there, that pocket there, that pocket there.
Final question? Yeah. Thank you very much for the talk. About the part that you said, like test things to ensure that things like the results will not get worse, but I still like trying to make some thoughts here. Do we need to like really test everything, and like how do you create a culture where the business people decide like what is strategy and what should be like investigated more like in a qualitative or market research, and what is really some learnings that we need to do an A/B test and require the data scientists to invest the resources for it?
Yeah. So there's a really good article about the role of the hippo in a test and learn culture, and that kind of alludes to some of what you're raising. So I think one school of thought is the larger strategy, this is the direction in which we're going. We are going to invest in this is a larger scale decision, but actually optimizing within that goal is then a test and learn, is then a test and learn approach. So there is absolutely that kind of, the other consideration is experimentation is actually really expensive. Yeah, so products need to be quite shippable, quite fully, because you're releasing that to real people who are paying you money, to use that service. So there is experimentation from a development cost perspective. It can be quite expensive. So there is then absolutely the role for various forms of user research and so on in order to help build confidence towards the right thing that you're looking for. So it's that kind of, where are you in the development process? How expensive is this form of test and learn? And then that helps you understand what should be the right way of gathering evidence at this point in time. Ultimately, we're in the business of what's the most rigorous evidence that we need at this point in time, you see? So that's kind of what we're then navigating to say, when does this make sense? When does that make sense? There are also initiatives around perception. So I want this experience to feel premium. How do you quantify that? You see, so there are also school areas where it's less measurable and really more about perception, because that also matters. People pay for the feel of the UI, you see, and so on as well.
Excellent. Thank you very much, Vidya.
Thank you.
Round of applause.
Thank you very much.